All right, so we're going to talk about the properties of equality. Okay, when it comes to now, this is just for real numbers. All right, real numbers encompass all the numbers, which is rational, irrational, whole numbers, natural, and decimals. So all of that is encompassed in here. So we're going to just learn some quick properties. They're not hard to understand. Okay, the first one is what? Reflexive. Reflexive. A is equal to A. Just like that, right? So x plus 12 is equal to x plus 12. 3 is equal to 3. 5 is equal to 5. Negative 2 is equal to negative 2. That's called a reflexive property, meaning a number is equal to itself. It does not change. Shade is equal to shade. It doesn't change. So it's a reflexive. Reflexive meaning you are who you are. You are yourself, right? So x plus 12 is equal to x plus 12. A is equal to A. That's a reflexive property. If you look at yourself in the mirror, you don't change. Do you? No.
I shape.
Well, it depends when you have your rearview mirror, when you drive a car, that's different. You change shape. Well, what do you see when you see yourself in the mirror? What do you see?
Oh, blackness.
Hey, come on. Why? The next property is called the symmetric, right? Symmetric. So basically, if A is equal to B, then B is equal to A. Does that make sense, right? If I give you an example here, 18 is equal to negative 2n plus a, that means negative 2n plus a is equal to 18. It sounds almost like the commutative law where you can switch things around. If a is equal to b, then b is equal to a. So if x is equal to y, then likewise y is equal to what? X. Meaning you can switch it, it does not change the equation. Does that make sense? Right, if I have x plus 5 is equal to 3, I can also say that 3 is equal to x plus 5. Okay, so that does not change the equation. All right. Next, transitive. The transitive law is also interesting. So basically, if A is equal to B and B is equal to C, then A is equal to C. Right. So let me give you an example. If x plus 1 is equal to 2y and 2y is equal to 5, then I can conclude that what? X plus 1 is also equal to 5. Does that make sense? It's called the transitive law. So if one is equal to the other and the other is equal to another thing, then that primary can also be equal to the tertiary, right? The third one. All right, so that's just called the transitive. Now substitution. Substitution is really easy stuff. So if A is equal to B, then A may be replaced by B and vice versa, right? If I have an equation, let's say I have 2x plus 5 equals to 3, and I say let x equals to 2, then I can replace the 2 in here, right? That means 2 times 2 plus 5 is equal to 3. Obviously, that's false because that's not how it is. But you understand what I'm trying to say? You can substitute a number by something else if you're given a value for it. So that's the substitution. Okay. Now the very next thing that we're going to discuss is solving one-step equations. One step meaning it requires literally one step, right? And I'm sure you guys did this in pre-algebra, algebra 1, and now algebra 2. It's the same thing that's going to repeat itself even until you go to calculus, if you are in calculus, right? So, Kelly, how are you going to solve this? So you have x minus 3.24. This is a decimal number, right? It's not 3 times, it's 3.24 equals to 42.1. How do you solve this?
You subtract it by the other side.
You subtract, which one are you solving for?
Well, technically you change your,
That has to move, right?
Yeah.
Since this is subtraction, what do I do to get rid of this?
You make it positive.
Positive, right? I'm going to add 3.24, right? 3.24. Now, we don't need the calculator for this. So we have 4, 3, 5. So x is equal to 45.34. Again, this is very basic stuff, okay? Now, some of these are a little confusing. Yes, sir.
Wouldn't that be 45.35?
No, 3-4.
Or
Because this is a 0 again. Alright? 42.1 is 42.1 plus 3.24. Right? You assume that there's a 0 here. Alright? So it's 45.34. Alright, now the next one is a little more complex. So we have -5 over 8x equals to 20. So how do I solve this? By using one step. Go.
You can multiply those by 8 or -5.
8 over -5. Yeah, that's right. Because I want to get rid of this, so I want, what do we call that? It's called start with R. Right? Reciprocal, right? So you times this by 8 over -5. And then you do the same thing here. Right? And now you can solve this in one step. We're done because this is going to cancel this and this is going to cancel this. So you're left with x. And then 20 times -8 over 5. We can simplify that, right? Again, we never leave fractions. We always have to simplify fractions, right? I know that 5 goes into 20 how many times? 4. And then it's 4 times -8. What does that give me?
32,
-32, right? So this should be -32. Again, this is like one step. In one step, you can solve these equations, all right? So these are called one-step equations. And then we're gonna jump into the more complex equations, which are the 2 steps or multi-step equation. Can I erase this?
No.
All right, go ahead. Good?
Yeah.
Good? All right. So here, well, how do I solve this equation? You have 5 parentheses x plus 3 plus 2, 1 minus x equals to 14.
distribution.
Distribution. All right, so how do I do that?
Distribute 5 into x and 3.
All right, and then,
Distribute 2 into 1x.
all right, so that gives me what?
5x plus 15
Okay.
plus 2 minus 2x
Mm-hmm.
equals 14.
All right, so what's the next step once you get here?
Combine like this.
Combine like terms, so what about combining?
The -2x and the 5x.
What is that going to give me?
3x.
3x, and then what else, Shay?
And then the 15 and the 2.
That gives me,
17.
all right. And then we have that, and then what's next?
Combine the 17 and the 14.
Minus 17, right? And we get 3x equals 3, and then last step
Divide
by
3.
3, right? So that's x equals -1. All right, right? -1. Now the next one is a little more complicated. It is not hard, it's just a little more complicated. Here, what we have, and what did you say? Solve for what? Variable, right? So we don't have numbers. And sometimes people get a little hung up on that. They go, well, this is too much. So how would I solve for h? Yes, sir.
Get it on its own.
Yeah, so how would I do that?
Distribute it.
Distribute it? Would that be a good idea if I distribute it?
No.
No, right? Because it's going to give us more work to do, right? So what we need to get rid of first to make this simple? No, I'm trying to solve for h. Parentheses, right? So how about I get rid of that?
Add those together.
Do that though.
We can add them because they are not like terms. It's b1 plus b2. So there's nothing I can do.
3.
No. That sounds good, but no. We can't,
5.
right? So that's the formula for what? What formula is this? No,
A circle?
no.
Trapezoid.
Trapezoid, right? Trapezoid. So we're trying to solve for h. So what's the easiest to move out? We can move this by what operation? Yes, sir.
We want to divide.
Divide, right? We're dividing. So I'm going to divide this by b1 plus b2. And why am I dividing and not adding or subtracting? Why?
Because it's multiplication.
Because it's a multiplication, right? So this implies a multiplication. That makes sense? Yes? No?
No, but
I don't know. We go over it again.
Wait, is that b sub 1 and b sub 2?
Yeah, that's b sub 1 and b sub 2. So basically,
why would you do that?
all right, because this is 1/2 h b1 plus b2. What? I don't have anything in between these numbers, right?
Yeah.
So that implies a multiplication. So this is 1/2 times h times B1 plus B2. So I want to solve for H, right? I want to get this by itself. I want this to be by itself, so I have to get rid of this for first step. But because it's a multiplication, you do the opposite.
Oh, okay, that makes no sense.
So therefore now you divide it, right? So I'm going to divide it. I'm going to divide. And now this is gone, right? So I'm going to rewrite this whole operation. So I have A over B1 plus B2 equals 1/2 and H, right? So now how do I get rid of the 1/2? Yes?
Is it reciprocal?
Reciprocal. So what would be the reciprocal here?
2.
2 over 1, right? So I times it by 2 over 1, and guess what? I have to do the same thing here, right? 2 over 1. So now this is gone. So now I have H equals 2A over B1 plus B2. And
That's it?
That's it.
Leave it like that?
you leave it like that. There's nothing else you can do here. Is there anything else you can do here?
No.
No. We can't simplify it. We can't do anything else. So we leave it like this. So I'll give you a couple of things to work on to make sure we understand this. So let me find it in the book. So I want you to solve one, two, eight. All right. So go ahead and solve these two. So first, solve for H, knowing that S is equal to 2 pi R squared plus 2 pi RH. I want you to solve for H. And here, if 6x minus 12 is 18, I want you to find the value of 6x plus 5. Okay?
Okay. Hang on.
We don't need to record anymore. We're good.
Is that an R?
Hmm?
I get it. How you doing?
Yeah.